Okay, class, today we look at all the different types of conics that we have done. There are 4 conic shapes that we have graphed, 4 distinct ones. We started with the parabola, and for the parabola we had 2 general forms of the equation. We had y equals 1 over 4c x minus h squared plus k. This would be for an up-down parabola. Then we also had x equals 1 over 4c y minus k squared plus h. This was for a left-right parabola. You'll notice a few things about the parabola. One of those is only x squared or y squared, not both. Because if you square both x and y, we now have a different shape. We have one of the other 3 that we've done. Let's move on to circles. For the circle, our general form was x minus h squared plus y minus k squared equals the radius squared. Something to note about the circle is that both x squared and y squared, and they have the same coefficient. In this case, the coefficient is 1 because we always move it to the other side as the radius. But if you didn't have the same coefficient, you would then have an ellipse. Our standard form for the equation of an ellipse was x minus h squared over a squared plus y minus k squared over b squared is equal to 1. This was for a horizontal ellipse. We also have x minus h squared over a squared plus y minus k squared, switch the a and the b squared plus y minus k squared over a squared is equal to 1. And that was for vertical. Some things to note about this is that we still have both x squared and y squared. It is actually x squared plus y squared. They're being added. And you know whether it's horizontal or vertical because a is always bigger. Finally, our relationship between a, b, and c was that a squared is equal to b squared plus c squared because a was the bigger one. Lastly, we have the hyperbola, which has a very similar equation to the ellipse with some differences, though. It was x minus h squared over a squared minus y minus k squared over b squared is equal to 1. This was for a horizontal. We also have y minus k squared over a squared minus x minus h squared over b squared is equal to 1 for a vertical. In this case, both x squared and y squared, but we have a subtraction, not an addition. Also, a is always first, not necessarily bigger, but it is always first, or it is the positive one, because we always write it as the first one minus the second. C squared is equal to a squared plus b squared in this one because c is bigger. So please take a minute and go over to your worksheet. In other words, this one. I will put my name at the top. Period 4, 5, or 7. And take a second to read this. All conic sections can be described by a general quadratic equation. This is not in graphing form. This is a form that we really never use. This is the one that we start with and then complete the square in order to get the graphing form. But that's our general form. You'll notice a few things in here. Ax squared, cy squared. And they can't all be 0. Some of them can be. Now, if b is equal to 0, meaning we don't have an xy term, then we have our 4 types of conics, and this is what we've been doing. We have the parabola, we have the circle, we have the ellipse, and we have the hyperbola. So let's look at our special cases. For a parabola, what that means when it says a is equal to 0 or c is equal to 0, but not both. And again, these are capital letters. We're not talking about our lowercase ones. But if not both, this means we have either x squared or y squared, which is what we set up at the top. For a circle, we have both x squared and y squared, and a and c have the same sign. We could technically have negative x squared minus y squared, but then we just multiply through by -1 and make the right side positive anyway. So this is x squared plus y squared. Now an ellipse is the one where a and c have the same sign, and a is not the same as c. That was different coefficients, and we can call the coefficients, we have one of them has an a and the other one has a b. In other words, you have a squared on the bottom of one and b squared on the bottom of the other. And a hyperbola is when a and c have opposite signs. In other words, you're subtracting x squared and y squared. You have either x squared minus y squared or y squared minus x squared. So take a moment and kind of catch up. I'm going to kind of pop over to the right side here and look at these images that we have. Remember that a circle is a special case of an ellipse. With a circle you have a radius squared, and with an ellipse you have an a squared and a b squared. For a parabola, we had a vertex, we had a focus, and we had a directrix, but really we were only concerned with that c value to try to graph it. In ellipse, you can also concern yourself with the c value, but we use the equation a squared is equal to b squared plus c squared. For a hyperbola, we use the equation c squared is equal to a squared plus b squared to figure out what the a values are, what the c values are, and what the b value is. So this is all acting as review. This is all in your notes from before. Let's kind of move down here to talk about the relationship of a and c again. Remember, in this case, when it says capital A, it really means the coefficient of x squared. When it says capital C, it means the coefficient of y squared. In a parabola, the equation has only how many square terms? 1. That's what we say when we mean either x squared or y squared, but not both. You have only one squared term. In a circle, the x squared and the y squared terms have the same coefficients. Remember, a circle is that special case where a squared is equal to b squared. Like it's an ellipse with the same a squared, b squared. We actually call that r squared. We don't really use a and b. In an ellipse, the x squared and the y squared terms have different coefficients, but they also have the same sign. In a hyperbola, they could have the same or different coefficients, but it's important that they have opposite sign.